G'day. In a previous video I bought myself a bandsaw pretty much on sort of a whim, and we did a bit of a walk around with that, and I showed you some of the things to look for with machine tools and all that sort of thing, even though a bandsaw is a pretty simple one. In this particular video I basically fix it up, bring it back to a condition that is probably, you know, akin to what it was when it was sold originally. So replace the pulley, sorted out some of the wiring, changed some bearings, straightened out a few guards, all that sort of stuff. This video is a collection of bits and pieces as I do parts of the bandsaw, and I just, you know, point out some of the things that I'm doing to it. One of the first things I'm doing is something that's been irritating me all week, or a couple of weeks now since I got this, is the guard. When the previous make-do tensioning device was made, the guard was hacked out with an angle grinder, and that just irritates me. So what I've done is I've cut out some bits of steel, and they're going to, that one's for there, they're going to sit in the holes like that. I'll put a backing bar in there, run around with a TIG torch, and patch the guard up. And I didn't cut this to size because that gets rather thin through there, and so I wanted to have a decent amount of material for the heat to go into. Okay. For this one, same sort of thing, but what I'll do is I think I'll weld up here and here, and then get in with a hammer to just sort of knock this down to where it needs to be before welding that bit. There it is. So I've welded some pieces in there, then cut them out. I had to use a jigsaw to do that. The bulge, yeah, I've got a reasonable match on the bulge. It's not quite perfect, but it's good enough. If I get some paint to match this, or decide on a different colour, I think there might be a couple of spots where I need a finger full of bog and maybe trim this circle up so it's neat. One problem I have got now is that, as I suspected it may, putting that heat in there has warped this panel, so I'm going to have to give it a bit of a twist to get it back into to shape. But other than that, yeah, first bit done. I'm making up a new pulley to replace this one. While pulling it off the shaft, and I should have realised it was zinc die cast, you can tell by the parting lines just there. It of course broke on me. Not surprising, I was using a 3-prong puller, and it broke. I've got an A series V-belt here. I've turned it inside out, and I'll see if I can do this so you can see what I mean about how these belts shouldn't ride on the bottom there. So the top of the belt is basically flush with the pulley, and you might just be able to, well, you should be able to see some light coming through, but that's how they should be sitting, right? So when they're riding like that, not only is it throwing your ratio out, but it's not going to be able to transmit as much horsepower, because you just got to, it's basically acting like a flat belt rather than a wedge belt. So I've got a piece of 2011, and I've taken it down to the OD, and I'm going to put a groove in there, put the sides in, giving myself probably 3 millimeters, and then part that off. I've roughed out my pulley blank. I've got to put a groove in there down to the root of the V groove. I've also put or reduced the diameter here for the boss where the set screw goes. I haven't taken that all the way down. That's just down enough to give me a convenient working surface. I've got my parting tool set up on the compound here, and the angle of a V-belt is 19 degrees per side. It actually, on smaller pulleys, it actually gets a little bit bigger, I think, but I'm not going to worry about that here. all I'm doing is just feeding in and putting the angle on the side of the pulley there. Once I've done that, I can then finish doing this bit, and well, it depends. If the motor arrives, I can measure that and bore the hole for that. Otherwise, I might just have to break down the setup and set it up again. It's not going to matter enormously because I've got the forge or chuck. I can just sort of center the boss up, because the boss has been turned with the groove. It should be all concentric, and then I can just bore away and make it fit for the motor shaft. Here's my, for want of a better term, pulley blank. Set 19 degrees on each side. That's down to the same diameter. Well, it's hard to tell with the draft, but it's approximately the same diameter as the existing one, and the diameter is about right. Now, as I was saying, and hopefully it'll work a little bit better this time, you might be able to see there's some daylight under there, and that's how it should be. So there's probably 4 or 5 millimeters. So in the terms of the ratio, the bandsaw would have been going slower than it was designed to. Whether that's a good thing or a bad thing, I don't know. But this at least gets it back to the right ratio. I replaced the bearing on this wheel, actually this bearing on this wheel, because when I played with them, the one on this side felt a little bit gritty. The other side's doing fine, and so to do that I used a punch on, just going through the centre hole to knock them out. The way this is done, there's a bore. It's got a circlip on each side, on the inside there, to hold the bearings. To replace these, ideally you use a press, but in a pinch or for something like this, you can get by if you gently tap with a hammer all around the perimeter. These are a precision device. Even if the bore is slightly too big and it crushes the bearing, it's going to alter the way the bearing works. So you want to try and very evenly just knock that down, and that'll suit. There are other bearings I need to replace. Nothing as critical as this. The main bearings down there for the motor are fine. This one's okay. It's just going to be some of the bearings for to bear the blade against. Just to show you how sensitive these bearings can be to mounting, that's with the nut there tightened up, just nipped up. Okay. If I tighten that, what was that? Maybe a sixth of a turn. Okay, and that's just because the inner race and the outer race are applying a little bit more pressure to the balls. As you can see, this is the base of the bandsaw, but it's upside down. And the reason I want it's upside down is I want to have a look at these feet. The tabs they're on have been bent over and have been for quite some time. You can see from the wear on the rubber stops here. Rather than straighten them out, what I want to do is put some casters on there so that this thing's easy to move. So I'm going to do that, but what I need to do is put in a strengthening bar, I think, across here, just to keep these, the sheet metal in line. There's my strengthening bar. It's actually a bit of an angle. And if I need to, because of the position of this, I can put a hole through there. That one's probably a bit too close to the other side of the angle, but I can put a hole through there and put another bolt there. These casters are interesting. This was given to me by a friend of mine. The same guy who gave me the motor, so I've got a very generous friend. Thank you for that. But with this red knob here, you can wind down this pad, and so you can wheel it to where you want it to go, and then wind that down and have a solid foot underneath it. Now, probably ideal for this sort of thing. My only concern is that these are only small wheels, and so I wonder whether the all the usual swarf and stuff that accumulates is going to get in the way. This is part of the new tracking device I've got. I have made them before, but when I started looking around on the internet for dimensions and other bits and pieces, I came across these, and you know, they're on eBay and a few other places, but the price I paid for this, I couldn't even buy the material for it. So to me it seemed pointless hogging it out of a lump of aluminium and spending hours doing so when I could just buy it off the shelf. And I got not only this part, but the spring, the stud that goes inside with all the knobs, the tracking knob, and there was also a flap in there with the spigot on for the bandsaw. The only problem is that it was metric, and the previous one was imperial, so I just had to make up a new nut, which when I get to fitting this, I'll show you. However, the really nice ones of these, the highly expensive ones, have graduations on them to show how much you wind the knob to tension for the various blade widths. So what I'm going to do, I've scaled off from the drawing where these marks are. I'm going to scribe them on there, then using a needle file, I think, put a line in there and engrave some numbers next to it, so that I've got that feature on this one, which costs probably about a third of the price of the ones with these flash markings on there. It's not foolproof. If the spring rate is different, then yeah, I'm in trouble, but it's better than nothing. And given that, you know, blade tension is important, I'd prefer to have at least something to guide me rather than absolutely nothing at all. So scribed a line, then deepened it with a needle file. With a hand engraver, just engraved some indicators, half, quarter, 3/4, 3/8, 1/8. I've also attacked the surface here with a file to flatten it off. This is the as moulded surface, and if I try putting the infill stuff over the top of it, all I get is a smear. So I've also flattened that out, and that helps with the marking. The secret to, I guess, hand engraving numbers like that, some people try it and they go all over the shop and say, oh, this is terrible, I can't do this. Once again, it's a matter of a bit of practice, but also you need to have a firm grasp on the engraving tool tip, whatever you're using, so that if the cutter does grab and tries to spear off somewhere, you're not holding it, you know, in a relaxed fashion that off it goes. You really got to be firm and hold it there so it will cut. And that's just something I've learned from experience. It's not perfect, but it's good enough. I'm just adjusting this for tracking. Now, you use that knob there to do it, but for those of you who haven't come across the term before, what you want to do is have the blade running in a constant position, probably somewhere like that, around the middle. If you don't have that tracking, you can see the wheel moving across, right? The wheel comes off the edge here. And if you have too much, right? I'm not game to get too much. Hang on, there we go. Right, the wheel tracks towards the back. And when I first got this was tracking right down the back. So I think there was probably a little bit too much tracking. So that'll do for the moment. I just thought I'd show you this. I'm making up some rubber washers to mount under the motor feet. To do it, what I've got is a wad punch. This is a Morn brand, and it's a UK build. It's quite good. It's got a little spring ejector in it, and that comes in quite handy because when I did the large size there, it's gone and put a little dimple there. So what I can do is line that spring ejector up on the dimple, and that's gone and cut out the middle bit there. Quite well enough for my liking. It's not quite on centre, but that's good enough. So, you know, if you ever have to do that sort of thing, a wad punch, as I said, the brand is Morn. They're a UK brand. If you're in Adelaide, I got mine from General Tools, but other people will have them. Not sponsored or anything like that, but you know, worth getting hold of if you have to do lots of these sort of rubber or soft material washers that you can punch out. I wanted to show you this. In the previous video about the bandsaw, I talked about just changing the bearings in the motor here. And so I thought, right, I'll go into the connection box here, the terminal box, undo the connections, and then I can disassemble it and take the motor apart. But what I found was this. So there's the start capacitor. So it's a cap start motor, cast iron frame, but all the terminals here are crimped, so I couldn't get that off. And when I contacted a friend and said, what do you think? Is it worth trying to do anything, replace these or whatever? He said, oh, I've got a motor that'll fit pretty much straight in there. The motor goes in here, and that's the cable that was connecting the old motor. But looking at that, there's a small problem. The earth is pulled out of the terminal, so I need to re-terminate that. But because I'm going to be putting the motor on rubber washers, it's even more important. I mean, from an electrical point of view, paint is no good anyway. But yeah, I need to make sure that I've got a really good earth to that motor, because if something goes wrong in there, that motor case becomes live and I touch it, I'm in all sorts of strife. So just a reminder to check your electrical connections and make sure that they're all good. For those of you who haven't set up V-belts on a machine before, what you do is, using a straight edge, sort of line the two pulleys up. You don't want the pulleys tracking in a crooked way, and I haven't tightened that one on the bottom up yet, but it's nearly there. It feels like it's got probably 0.5 millimetre or so worth of movement out, which is good. So yes, I'll do that. I didn't do the motor bolts up with the nylocks that I was going to use. I just used plain nuts, because until I get that belt on there and get it tensioned, nylocks might be more trouble than they're worth. So what I'm going to do is get the belt on, tension it up, and then replace the nuts with the nylocks before I start using this in anger. Doing pretty much the last of the setup here. This bearing here, I've just replaced that. It was just popping the circlip off and then putting it back on. That sits just behind the blade, so I'm going to adjust that so it's maybe not quite touching. And that way that it's sitting, when the saw is running without any cutting, it's not actually doing terribly much. But when the blade is being pushed back, that bearing is supporting. Now these blocks here, I was surprised to see that they're steel. They are way out, and so I'm going to push them in. And once again, this is for the stability of the blade. When you're cutting, you're going to have the I might take that back a bit too, because you don't want it rubbing on the teeth. So it's better than it was. I might have to do that again, but the whole idea is that the blade is free to run on the wheels. The blocks up here and the ones underneath the table stop it moving too much side to side. The bearing here and the one underneath the table stop it being pushed back too much. When you're cutting, you're adjusting this right down as close as you can to the work, both for safety reasons but also for giving the blade maximum support over the cutting area. But there you go. That's how I fix up bandsaws. Yeah, new belts, new bearings, straighten out guards, correct wiring, all that sort of stuff. But now I've got a working bandsaw. I've cut a little bit of wood on it. The speed is such that it's a wood bandsaw still, and it works quite nicely. Probably in the future I'll be looking at putting some belts on there to drop the speed down to metalworking speeds, but that's a future episode. So thanks for watching. See you for the next one.